Here's another quick mesh analysis example. Here they're asking us to find I in the circuit above. So here's I here. It would be just equivalent to I2. So that's what we're looking for. So let's go ahead and look at this. They've already defined some mesh currents for us. So here we've got mesh current I1. So if we were to start there, we can see that we have two resistors that I1 would go through. So we can write that then as 4 plus 2 is 6, so it's 6I1. But then we also have this mesh current I2 right here. And we can see that I2 also goes through the 4 ohm resistor, and it's working against us. So therefore we need to say minus 4I2. And that's pretty much all the interaction we have with I1. And so we're left with a voltage source here that's in this loop. And we can see that that voltage source is working in the same direction as our current flow. So therefore we can say that it is equal to 12 volts. So now if we want to go and look at the mesh equation associated with I2, that loop, we can see there that we have these three resistors that I2 goes through. So that's 5 and 4 is 9, plus one more is 10. So then that's going to be 10I2. But we also see the 4 ohm resistor has I1 going through it, working against our current. So then that'll be minus 4I1. And again, if we define I3 up here, we'll say it's green, we see that it's also going through this 1 ohm resistor, and it's working against our mesh current. So then that's going to be minus I3, or 1 times I3, which will just be I3. And that's all of our interaction we have on loop 2. And there are no voltage sources. So that being the case, we can just say it's equal to 0. And so finally, if we look at our third loop actually works out to be pretty simple in that I3 is kind of predefined because of this source here. So because of that, and actually we could do that a little differently because of this source here. And so because of that, it's simply equal to 2I1. So that being the case, we can do some quick substitution. We can plug this into this equation here. And so when we do that, we can rewrite these to be a little simpler. And so what we have then is, for the first mesh loop, what we have is 6I1 minus 4I2. That's going to equal to 12. And then for the mesh associated with I2, we would have minus 6I1 plus 10I2, and that's going to be equal to 0. And so here we have two equations, two unknowns. You can use whichever method you'd like to. There's several different ways to solve that. There's matrix, linear algebra, and there's elimination of variables. In this case, what we can do, which may be the simplest, is just add these two equations together. So when we add them together, 6i minus 6i, of course, is 0. 10i2 minus 4i2 is going to be 6i2. 12 minus 0 is 12. So therefore, I2 is going to equal to 2 amps. And this is, in fact, equal to I. So I, in this case, is in the non-shared part of the I2 loop. So therefore, it is equal to I2. So this is the solution to that problem.